Welcome, guys. So today I want to solve this problem because I already seen this problem in many interview questions, and basically I solved this problem many times, but sometimes I forget how to solve it. Okay, so I want to make a video and do some record. So I think the question is understandable. Expected number of coin tosses to get n consecutive heads. So basically, suppose you have a fair coin. So each time you can get each time you can get a head or a T, and I want to ask you about how many expecting times that you can get n consecutive heads. Okay, so the first stupid example is n equals to 1. Then so in the beginning, the first time you can, if you toss a head, then done. Suppose in the first time you toss a tail, then second time you toss a head, then you success. And the third situation is the first 2 times fails, then you success. The first 3 times fail, and then the first you success. So you write down the series, you get this. Okay, so for the remaining is just compute this term, and we will use this result. Okay, so basically, let me summarize some result we need. So I think let me see. I think this one is everybody knows. Basically, just 1/4 to 1/2 to n, and this is geometric series, right? So I think everybody knows how the answer is this. So let me. Right, so this is the answer. So you can check for n equals to 2. Okay. And the second important quantities what we need is this one. Okay, so how to solve it? Basically, this is suppose I call it x, and I can take I can multiply it by half. Then we get this is the okay, and minus. So we have x over 2, and this term cancelled. So this is 1. This is 1. This is 1. So basically, we have a half 1/4, 1/8 to 1/2 to n plus 2 to a large n, 2 to a large n plus n 2 to a large n plus 1. So x is equals to this term is this term, right? So x equal to twice okay. So this is minus because this term minus this term. Okay, so this term is these two series is we need to remember, and then go back to here. Then we let this large n to infinity. So these two terms vanish. So the answer is 2. The answer is 2. Okay. So to get n consecutive heads, then basically we will prove e of n is 2 times 2 to n minus 1. So e of 1 is 2, e of 2 is 6, e of 3 is 14, and e of 5 is 62. Okay, so the first way is we need to solve it. I will solve it by the recur. Basically, we just directly solve e of n. Okay, so probably I use this way is better. So e of n has different kind of situation. The first situation is you first fails. So that means that means you will contribute a half, because in the beginning you get tail, so you fail, and you waste one chance. And the second possibility is you get the first is head, you success, but then you get a tail, so you fail. So this is 104, and you waste two times. And the second is you get head, tail, so basically you success twice, but you fail. And then you will contribute to 3. And you keep going. So the final two situation is basically you get a head for a -1 times, but unfortunately in n times you fail. So basically this is 2 to the n, but you fail n times. And the lucky chance, the luckiest result is basically you get n consecutive heads. This is 1/2 to n, and you use n times. So sum all of these will be E of n. Okay, so we can solve it. Do not worry, because I remember the expression. So in order to for this, I use E to denote it, because this is more easy. To the n, E plus n plus n 2 to n. So we can expand it. We get E, we had a half 1/4 to 2 to n plus a half for 2 and 2 to the n plus n 2 to the n. Okay, so the good thing is this is a series we have seen. This is series we have seen. So this E is E times this one plus, okay, plus this term. So this is twice 1/n plus n/n. Right? Minus n/n. So this is this term. And then remember there are final successful term. So basically these two terms cancelled. And then you express this E to the left hand side, you get this one. 2 minus 1/2 to the n. So we get E is, you multiply 2 to the n. You get 2 times 2 to the n minus 1. So congratulations, then we solve it. So this is the answer. And this is coincidence with the Huawei observation. Either n equals 1, and basically you can check for n equals 2, n equals 3 by yourself. Okay, and I will present the second way, just the recursion formula. So this is much simple. Suppose you want to get n consecutive heads. And one expectation is that suppose you already get n minus 1 consecutive heads. So basically, you can view E of n basically is a half times E of n minus 1 plus 1. So this term means that you spend n minus 1 consecutive times to get n minus 1 consecutive heads, and the last chance you success. So you only need to spend a half. There's a probability of half, and then you spend additional time. And another case is you fail, right? You in this test you get tail. So basically then you spend En minus 1, but you need to spend all the En plus that time you fail. So this is the recursion formula for this En, or I should write it E of n minus 1 times plus E of n. Okay, so from this you can get E of n equals to E of n minus 1 plus a half is 1 plus half En. So basically you can show that E of n is 2e of n minus 1 and plus 2. Okay, so the final thing is we can solve this if we know e of 1 is 2. There are multiple ways to solve it, but we can use the mathematical induction. Because n equals to 1 is correct, so we can assume that n equals to k is correct. And then we compute n equals to k plus 1. So basically, n equals to k plus 1 is equal to 2 times e equals k plus 2. This is 2 times 2 to the k minus 1 plus 2. Basically, you take a 2, so you get 2 to the k plus 1 minus 2 plus 1. So this is 2 to the k plus 1 minus 1. So this is e of k plus 1. Basically, use a mathematical induction, and we can prove the answer is it. Okay, basically that's it. And I want to say more is that basically, suppose you can generalize this result into, suppose the successive result is p. So suppose your success is p, and you want to the expectation number to get n consecutive results, and each time your success is p. And you can use the same method to prove that the expectation value is 1 over p, 1 over 1 over p squared, up to 1 over p to n. So this is the general result for p. If you plug p equals to half, then basically you can get the 2 plus 2 squared 2 to n, and then you can use the geometry series to prove this is the result. So basically, this is what I want to what I want to present this video, and I will see you guys in next video. Thanks.